Over the last 50 years, humanity has cured cancer. We've cured Alzheimer's. We've reversed diabetes, stopped heart disease in its tracks, cured obesity. There's just one catch, a massive multi-billion-dollar catch. We haven't cured any of it in a human being. We've cured it in rats. Here's a statistic the pharmaceutical industry doesn't put on billboards. Roughly 90% of drugs that sail through animal trials fail the moment they reach human trials. 90%. Think about what that means. Decades of research, trillions of dollars, poured into compounds that work like magic on a rodent, then do nothing, or worse, turn dangerous the moment they meet you or me. So here's the question that should bother you. If we're this biologically different from a rat, why is a rat still the gatekeeper for human medicine? Are we trading accuracy for convenience? That's what we're digging into today, the widening gap between rat biology and human behavior. And the question scientists are only now willing to ask out loud, is it finally time to leave the lab rat behind? To understand why we haven't already, scientists deserve some credit. They didn't pick rats out of a hat. Genetically, we share somewhere between 95 and 99% of our DNA with rodents. Our organs sit in roughly the same places, doing roughly the same jobs. Spike a rat's blood pressure with a chemical, and its heart reacts almost exactly the way yours would. So far, so reasonable. But here's where it gets interesting. We share even more DNA with chimpanzees, with pigs, with macaques, animals that are closer to us anatomically, behaviorally, cognitively, in almost every way that matters. So why aren't they the standard? The honest answer isn't science, it's logistics. A lab rat lives 2 to 3 years. It's cheap to house. It breeds constantly. And ethically, society sleeps easier testing on a rat than on a chimpanzee. All fair reasons, until you see what they cost us. Because somewhere along the way, we quietly decided that 95% genetic similarity was close enough. But in biology, that missing 5% isn't a small gap. It's a canyon. And nowhere does that canyon open wider than inside the human brain. The brain problem. Antidepressants, anti-anxiety medication, schizophrenia treatment. This is where the canyon becomes a chasm. Humans have a highly developed prefrontal cortex, the part of the brain responsible for complex emotion, existential dread, long-term trauma, social anxiety. Rats essentially don't have one. So sit with this for a second. How do you know if a rat is depressed? And more importantly, how do you know when a drug has cured it? For decades, the answer was something called the forced swim test. Drop a rat into a cylinder of water it can't escape. At first it swims, frantic, fighting for its life. Eventually it gives up, it floats. Scientists called that floating behavioral despair, the rat equivalent of depression. Give the rat an antidepressant, and if it swam a little longer before giving up, the drug was declared a win. Now ask yourself, does that sound anything like human depression to you? Floating in a tank isn't sadness, it's survival. The rat conserving energy because fighting is now pointless. It has nothing to do with why a teenager feels invisible in a room full of people, or why an adult lies awake at 3 a.m. running numbers on a mortgage they can't afford. We've been trying to cure the most complex emotional organ in the known universe with an animal that doesn't have the hardware to feel what we feel. That's the real reason so many psychiatric drugs collapse the moment they reach human trials. We were never testing for human behavior, we were testing for rat reflexes. And it's not only the brain, it's everything around it. When you get sick, that illness carries your whole life inside it. The microplastics in your water, the stress from a job that doesn't pay you enough, the flu you fought off 10 years ago, the processed food you didn't think twice about yesterday. Your immune system isn't clean. It's a battle-scarred, chaotic landscape shaped by every fight it's ever survived. Now picture the lab rat. It's one of thousands, genetically identical to the rest. Bred in a sterile facility, breathing filtered air, eating food engineered down to the nutrient. It has never ridden a crowded bus, never caught a cold from a coworker, never fought off anything at all. Its immune system has never seen a real war. So when researchers test a groundbreaking cancer immunotherapy on that spotless rat, it works beautifully. Of course it does. Its immune system does exactly what the drug tells it to, because it's never had to think for itself. Then that same drug meets a 60-year-old human, decades of smoking, chronic stress, a completely different immune history, and it falls apart. The body doesn't cooperate. It rejects the drug outright. There's a name scientists give this moment, when something works perfectly in the lab and shatters in real life, the translational gap. It claims more casualties than the pharmaceutical industry likes to admit. So why hasn't the system already changed? Ask a scientist, and most won't even argue with you. They know it's flawed. For decades, their answer has been the same. Sure, but what's the alternative? We can't just test unproven chemicals on people. And for a long time, they were right. But we're standing at a genuine turning point now. We don't need giant rats. We need actual human biology. And for the first time in history, we have the technology to get it. Enter organs on a chip. Scientists can now take living human stem cells and grow them directly onto a microchip, something about the size of a USB drive. What forms on that chip is a living, breathing, pulsing model of a human lung, a human heart, a human liver. Instead of guessing how a drug behaves in a rat's liver, we pump it straight through a chip lined with real human liver cells and watch the toxicity happen in real time, no guesswork required. Now stack artificial intelligence on top of that, AI that can simulate exactly how a drug molecule will fold, twist, and bind to human proteins before a single dose is ever manufactured. Suddenly, the lab rat doesn't look like a gold standard. It looks like outdated 20th century hardware. None of this makes the rat a villain. Rats got us this far. They taught us the baseline mechanics of biology, and we owe them, genuinely, for the foundation they built under all of modern medicine. But our diseases have outgrown them. Alzheimer's, autoimmune disease, severe psychiatric disorders. You cannot fold that kind of complexity into a rat-sized box. It simply doesn't fit. We are not giant rats. It's time our medicine finally stopped treating us like we are. There's still a long road before chips fully replace cages. But for the first time, science isn't just guessing at what happens inside us. It's starting to actually watch. If this changed how you think about drug testing, hit like and drop a comment. Do you think organs on a chip replaces animal testing in our lifetime? Subscribe for more deep dives into the science of us. See you in the next one.